Hello, Miss Vaidyanathan. How are you?
Hey, Miss Khandale, I'm good. How are you?
I'm good too. I'm really thankful that you were able to take out such precious time out of your time. Thank you so much. I
Of
know you're
course.
very busy, but let me go ahead and introduce you. Hello,
Sure.
this is Miss Mahitha Vaidyanathan. She is an AI engineer at Coursera. She has kindly agreed to talk with me about my project, and this is going to be a engineering focused or oriented interview. So let's dive into it. Uh, okay. So before this interview, I went ahead and explained and showed the project to her. And to start, can you please describe your background and why you feel comfortable discussing like technical systems?
Sure, why not? So basically, I have a background in computer science and engineering, and I've taken a couple of courses in machine learning and data analysis as well. I'm really familiar with neural networks, clustering, and model evaluation, so I'm definitely comfortable discussing the technical design choices in your projects. So I'm really looking forward to that.
That's really nice. That's the kind of expertise we need so that we can, somebody with such fresh eyes and expert skills can look at the project and help us with it. Um, After I explain the project to you, what stood out as something interesting, or did something stood out as a something interesting technical decision?
Yeah, definitely. Like the most interesting part was your decision to not rely on a neural network. Like that really immediately caught my attention because most prediction systems today, by default, use deep learning, even when it may not be necessary. You know what I'm talking about?
Yeah, I completely get that. Right now, there's such a big craze for AI that everybody just drives, is trying to make their system AI. And the first step during that is a neural network. So, yeah, I understand that that has been the main focus of our project as well.
Yeah,
Mm.
that's really great to see.
Why do you think avoiding neural networks is a good choice or is a reasonable choice here?
Well, so I thought about this and I thought that the baseball data is actually structured and tabular. So many of the relationships between features are well understood and often linear or close to linear at least. And neural networks shine when you have unstructured data like images or audio. But for sports statistics, simpler models can also just perform as well with just better interpretability, right? So.
True, true. I because I feel like the most basic thing when we go ahead and join an AI class, the first thing they teach about is like clustering functions. And like, can you explain a few things about clustering for us so that even like how do we implement it much better in our project?
Sure, why not? So, I think clustering works as a way to compress information. So, instead of feeding hundreds of raw statistics into the model, you can group them into clusters that represent similar styles or performance patterns, like the teams. So, each cluster can act like a prototype, and the teams can be compared based on how close they are to these particular prototypes.
True, true. Um, would you consider clustering or anything like this a form of representation learning?
Yeah, definitely. Neural networks learn representations implicitly through layers, but your system learns them explicitly, right, through clustering. And that's a more classical and transparent approach to representation learning.
Our idea was to do something which is memory plus interpolation. Do you think our idea relates to that model?
Yeah, like the clusters serve as memory because they store historical patterns, and the interpolation happens when new teams or games are evaluated based on decision on the distance to these stored prototypes, and that fits very well with the memory plus interpolator framework.
We were talking about deep learning, and I just had that what are advantages does our system have over deep learning? And we wanted to know a bit more with a maintenance perspective.
Yeah, I think it's much more easier to debug, retrain, and also explain. So if something goes wrong, you can actually inspect the clusters and see why the model made a certain decision. So with deep learning, you often don't know what went wrong. So that's
True, true. How do you think this approach affects generalization?
I think it really improves the generalization because the model focuses on broad patterns rather than just memorizing specific players or games. It should better adapt, well, it should adapt better with rosters when the rosters change or when new seasons start. So that's what I think.
True, true. Are there any risks associated with clustering?
Main risk here would be choosing the number of clusters or clustering on poorly selected features. Like if the clusters don't reflect meaningful differences, the model could lose some predictive power.
Do you think our system can be improved technically in the future?
Yeah, I mean, you could experiment with different clustering models like the Gaussian mixture models or the hierarchical clustering. You could also kind of update clusters dynamically during the season to account for changes in the team performances, maybe.
True, true. Actually, that is what we are hoping for, like, because I feel we didn't have it is a month-long project, but we were not able to think about it in just in that 1 month. Our idea is to expand it more in the winter and moving forward. So I want to know a bit more. I wanted to know a bit more about like how like these methods that we have used, like clustering, how can they be improved? And I feel learning about these, like you said, the Gaussian mixture model, I think I might look more into it and try to implement it further.
Sure.
Uh, do you think this system satisfies the requirement of being a valid alternative to ANN based systems?
Yeah, I definitely think so. I mean, it's not just an alternative, it is definitely a strong example of when simpler models are actually more appropriate.
If this was applied outside baseball, where do you think it would work well?
I mean, I think this would work well anywhere where you have structured data and recurring patterns, like maybe finance, health risk assessment, or maybe fraud detection. Like the principles transfer very well in these cases.
Actually, that's what I wanted to hear from you because we realized that baseball is a very small fragment of what our achievement should be, and we thought that expanding a bit more, just getting the model and putting different inputs and giving it different data so that we are able to predict different items is what our aim is. And baseball is just something, uh, a stepping stone, you might say, to get a model to work perfectly without doing any harm. And the more we go into finance and healthcare risk, those kind of scary things such as fraud detection, then we will have a stable model.
Yeah.
Um, is there anything else you'd like to add from a technical standpoint?
I think the biggest takeaway is that thoughtful model design often matters more than just like the model complexity. So that's what I would like to add here.
That's truly said. Especially nowadays, I feel like everybody is running after designs that are too complex for the resources that we have currently. We need to adjust to simpler ones and find out ways where we can find better results using those simpler designs. Um,
Yeah.
Thank you, Miss Vaidyanathan. Thank you so much for giving us your precious time. We needed a lot of technical expertise for during this project, and I feel your standpoint will help us give it broaden our horizons for it.
Definitely. Thank you so much for interviewing me and all the best for your project.
Thank you. Have a good one.
You too.